alaikum everyone. So today we will discuss Cambridge International AS Level Physics Paper 2 October November 2024 Variant 22. Question number 1 part A state what is meant by a vector quantity. So a quantity that has both magnitude as well as direction is called as the vector quantity. So we'll write a quantity which has magnitude and direction. In part B, a sapphire falls vertically through a liquid that has density 830 kg per meter cube. The sapphire has radius r and constant velocity v as shown in figure 1.1. So as we can see in the diagram, this sapphire is falling inside this liquid and it's traveling with a velocity v and the density of the liquid is 830. The drag force D acting on this affair is given by D is equal to 6 pi r NB, where N is a property of the liquid. Determine the SI base units of N. So, in such questions, whenever we have to find the SI base units of a certain variable, so we should always make that variable as the subject first. So make n as subject. So n को subject बनाने का मतलब ये है कि n should be on one side while all the other variables and numbers should be on the other side. So this expression turns into d over 6 pi r v is equal to n. So इस expression में 6 pi r v was being multiplied with n on the right hand side. When you shift it to the left, so it will be divided by d. So once you have made n as the subject, now we need to know the SI base units of each of these variables. So since d is a force, so D is the drag force. So force का formula होता है F is equals to ma. So m is the mass. Mass का unit is kg. Acceleration is in meter per second square. So that means the SI base unit of force is kg meter per second square. So whenever we have to find the SI base units, we always neglect these constant numbers. So instead of d, let's write its SI base unit kg meter per second square whole divided by r is the radius which is in meter and v is the velocity which is in meter per second. So if we simplify it, so we can just cancel this m with the other m and kg, m has a power of 1 and it's in the denominator. So when you shift it up, its power sign changes to -1. And if these s to the power of -2 into s to the power of -1 when it goes up, it becomes s to the power of +1. So kg m to the power of -1, if the bases are same, we add the powers, so -2 plus 1. So the final answer is kg m to the power of -1 s to the power of -1. In second part, he is saying state an equation showing the relationship between the magnitudes of the weight W, drag force D, and the upthrust U acting on the sapphire. So if we look at this diagram, so this is the sapphire. The weight is always acting vertically downwards. And if we talk about the upthrust force, so upthrust force is always acting in the upward direction. So if the sapphire is falling in the liquid, so the velocity is in the downward direction, so the upthrust force will be acting in the upward direction. And since the sapphire is moving in the liquid in the downward direction, so the drag force is the force that opposes the motion of a sapphire or any object inside a liquid. So it means that the drag force will also be acting in the upward direction. So now, since the object is traveling at a constant velocity, so the constant velocity means that the resultant force will be zero. And resultant force zero तब होती है when the downward force and the sum of the upward forces are equal. So we can say that this weight will be equal to the sum of upthrust and the drag force. So the expression or the equation is W is equals to U plus D. In third part, the volume of the sapphire is given, which is 4.6 centimeter cube. The drag force D is 0.32 Newton. Now he wants us to calculate the weight of the sapphire. So since the drag force is known to us, and in the previous part, we have found an expression that connects weight, upthrust, and the drag force D. So drag force we already know, upthrust we can calculate it using the formula upthrust is equals to rho g v, where rho is the density, G is the gravitational field strength, which is 9.8, and V is the volume. Now let's just put the values in this expression. So upthrust density was already given, which is 830. So density is 830 times 10.8 and the volume is 4.6 centimeter cube. Now, centimeter cube, we have to convert it into meter cube. So, how do we convert it into meter cube? By dividing it by 100 cube. So, the upthrust force is equal to 0.037 Newton. Now just remember meter, centimeter. When we have to convert meter into centimeter, we multiply it with 100. When we have to convert it from centimeter to meter, we have to divide it by 100. However, let's say if it's meter square to centimeter square. So if you have to convert meter square into centimeter square, so we have to multiply it with 100 square, and if we have to convert centimeter square into meter square, so we divide it by 100 square. So same goes for the cubic. If we have to convert meter cube to centimeter cube, multiply it with 100 cube, and if we have to convert centimeter cube to meter cube, we have to divide it by 100 cube. So once you have got the value for the upthrust force, now put this value in this equation 0.037 and the drag force is 0.32, and if we add them together, so we get 0.357 Newton. So this is the weight of the sapphire. Now moving on to the next question. Okay, before that we have to round off the answer to two significant figure. So the final answer will be 0.36 Newton. Define momentum. So momentum is defined as the product of mass and velocity. Mass and velocity. So if you remember the formula for momentum, momentum is denoted with small p m into v. So p is the momentum, m is the mass, and v is the velocity. So if we talk about the unit for momentum, mass is in kg, velocity is in meter per second. So the unit for momentum is kg meter per second. A child stands on a scooter on horizontal ground. The combined mass of the child and the scooter is 16 kg. The child starts from rest and pushes once on the ground with her foot, which causes her to accelerate. The push lasts for a time of 1.1 seconds. So the initial velocity is 0 since he was at rest, and the speed of the child and the scooter after the push. So the final velocity is zero point 0.6 meter per second. And how much time it took? It took 1.1 second. Determine the average resultant force acting horizontally on the child and the scooter during the push. So the formula is F is equals to mv minus mu over t, where m is the mass, v is the final velocity, and u is the initial velocity. So if we just put the values in the formula, the mass is 16 kg. So m is 16, final velocity is zero point 0.6 minus 16 times 0 whole divided by 1.1. So we get 8.7 Newton. You can put this entire expression on your calculator and it will give you the final answer, that is 8.7 Newton. Now, next part, he is saying later the child in part B travels down a slope at a constant angle to the horizontal as shown in figure 2.1. At point A, her speed is zero point 0.6. So at this point, her initial speed is zero point 0.6 meter per second. She has a constant acceleration of 0.85 meter per second square parallel to the slope. After a time of 3.7 second, she reaches this point B. Calculate the distance x traveled by the child along the slope from A to B. Now, since she is traveling on a straight line, so we can use a straight line equation of motion, which is S is equals to ut plus half at square. So basically, you have to identify which values are already known to you. So based on that, we choose the equation. Because the other two equations are v is equals to u plus at and v square is equals to u square plus 2as. Now, since we wanted to find the distance, so we will not use the first equation. However, in the second equation, we don't know his final velocity at point B. So we will use this equation. Now put the values, u is zero point 0.6, time is 3.7 plus 1 by 2, acceleration is 0.85 and time is 3.7 square. Put this entire expression on your calculator and it gives you the final answer, which is 8 meter. So if you have to express your answer in two significant figure, so we will write it as 8.0 meter. At point B, the child in part C applies the brake with a constant force to maintain a constant velocity. Point C is 18 meter from point B. So the distance between point B and C is 18 meter. The work done by the braking force between B and C is 250 joule. Determine the magnitude of the braking force. Now the formula for the work done. So work done is the product of force into distance moved in the direction of the force. So we want to find the magnitude for the braking force. So force will be equal to work done over distance. So the value of work done is 250 and the distance is 18 meter. So if we divide 250 by 18, we get 14 Newton. On figure 2.3, sketch the variation of the kinetic energy of the child and scooter with distance traveled from A to C. Numerical values for kinetic energy are not required. So he wants us to sketch the graph of kinetic energy against the distance from point A to point C. So let's just look at the diagram again. So we know at point A, his initial speed was 0.6 meter. At point B, we don't know, but since he was accelerating, so the final speed at B must be greater than the final speed at A. So if the final speed at B is greater than the final speed at A, it means that the kinetic energy at point B should be greater than the kinetic energy at point A. But we don't know the relation between kinetic energy and distance. But we do know the formula for kinetic energy, which is 1 over 2 mv square. Now, since we have to plot a graph for kinetic energy against distance, and we know one equation of motion which is v square is equals to u square plus 2as. So if we substitute v square as u square plus 2as, and let us multiply 1 over 2m with u square, we get 1 over 2 mu square plus 1 over 2m times 2as. So 2 and 2 gets cancelled. So I can write it as mas plus 1 by 2 mu square. Now, if I just compare it with y is equal to mx plus c. So we have plotted kinetic energy on the y-axis and we have plotted distance on the x-axis. ma is constant, and since the initial velocity is constant, so this thing is also constant. Based on this equation, we say that kinetic energy against distance graph is going to be a straight line graph which does not passes through the origin, because his initial velocity is non-zero. So he at zero, his kinetic energy, he is going to have a certain value, but it his kinetic energy is increasing with a constant gradient against the distance time graph. So this is how it's going to look like for the position from A to B. Now from B to C, from B to C, The child in C applies the brake with a constant force to maintain a constant velocity. So B to C, it has a constant velocity. So if she has a constant velocity, it means her kinetic energy will also remain constant. From B to C, we have a horizontal line. So kinetic energy stays constant from B to C. From A to B, the kinetic energy increases with the increase in distance and it increases uniformly. In question number 3, the variation of stress with strain for a metal P is shown in figure 3.1. Point E is the elastic limit of the metal. Use figure 3.1 to determine the Young modulus for P. So, the gradient of stress against strain graph gives us Young modulus. Remember, gradient of stress against strain is equal to Young modulus. So it means that from the graph, we will calculate the gradient, and whenever you have to find the gradient of a straight line, we always need 2 points. So 1 point will take this origin 0 comma 0, and another point, let's consider this point. You can consider any other point on this line. Now, we always write down the x coordinate first, and the x coordinate is 0.5. However, the strain is given in percent. So, we will write it as 0.5 divided by 100. Getting rid of that percentage sign, we get 0.05. 0.005. So the x coordinate is 0.005 and the y coordinate is we have 1 unit difference along the y-axis. So this is going to be 12, but we have 10 to the power of 7. So we write it as 12 into 10 to the power of 7. So once you have 2 points, mark x1, y1, x2, y2. Let's use the gradient formula, which is y2 minus y1 over x2 minus x1. So 12 into 10 to the power of 7 minus 0 whole divided by 0.005 minus 0, and the Young modulus is 2.4 into 10 to the power of 10. So this is going to be the value for the Young modulus. On the line in figure 3.1, draw a cross to show the limit of proportionality. Label this point Q. So the limit of proportionality is the point where the stress is directly proportional to strain. It means it stays as a straight line. So we mark a cross at this point because until this point from 0 to 1, it's a straight line graph that passes through the origin. But after 1%, it turns into a curve which shows that the limit of proportionality has been breached. State the conditions necessary for an object to be in equilibrium. So it's a 2-mark question and we have to give 2 points for that. So the first point is the sum of clockwise moments is equal to the sum of anti-clockwise moments. Sum of clockwise movement is equal to the sum of anti-clockwise moments. And the second point is the resultant force should be zero. Resultant force is 0 Newton. Or the sum of upward and the downward forces will be equal, or the sum of leftward and the rightward force. So basically, the resultant force is 0 Newton. A wire is used to hold a uniform shelf. So this is the wire. This is the wire horizontally, and this is your shelf in equilibrium. So the shelf is in equilibrium and is held by the wire. The wire is connected to the midpoint of shelf AB. So this is the midpoint. This is your midpoint. So we can say that this distance is going to be half of 0.65, which is 0.65 divided by 2. We get how much? 0.65. Yes, so we get 0.325 meter. So this is, and this whole distance is also 0.325 meter. So the wire is connected to the midpoint of shelf AB at an angle of 50 degrees to the horizontal. The shelf is attached to a wall by a hinge at A. The length of shelf AB is 0.65 meter and its weight is 33 Newton. So the weight of this shelf is 33 Newton, and the weight is always acting at the geometrical center of a uniform shape. A cup of weight 1.5 Newton. So we know the weight of this cup as well, and that is 1.5 Newton, with its center of gravity at a horizontal distance of 0.12 meter from point B. So the distance of the center of gravity of cup from B is 0.12 by taking moments about point A. Determine the tension in the wire. So since the wire is pulling the shelf towards the walls, this is going to be the direction of the tension T in the wire. Now let us draw the components of this wire. So the components of the tension will be, so we have this vertical component and we have this other horizontal component, and it's going to be a right angle triangle. Now this whole angle is 90. So if this angle is 50, so this angle is going to be 90 minus 50, which is 40 degrees. Now we know this angle and we know tension T, which is the hypotenuse. So the component which is opposite to the angle, we write sine with the angle. So it's going to be T sine 40, and that component which is adjacent to the 90-degree angle and to the given angle, we write T cos of 40. So we have the components of this tension. Now by taking up moments about point A, determine the tension in the wire. So sum of clockwise moments should be equal to the sum of anti-clockwise moments. Now we need to figure out which forces are producing a clockwise moment and which forces are producing an anti-clockwise moment. So this force or the weight 33 Newton produces a clockwise moment, and this 1.5 Newton force also produces a clockwise moment. However, this force T cos of 40 produces an anti-clockwise moment. However, we neglect this component. Why? Because this component of the force is parallel to the distance. And whenever we have to take the moments, so moment is defined as the product of force into perpendicular distance. So the force and the distance, they have to be perpendicular with each other. So we can see that this 33 Newton force and this is your pivot or the hinge. So the 33 Newton force, it has a distance of 0.325 from the pivot. So we will multiply 33 with 0.325 plus, if we talk about this 1.5 Newton force, the distance of this 1.5 Newton force from its pivot point is how much? This is going to be the distance. So if we this whole length is 0.65 and this distance is 0.12, so this distance is going to be 0.65 minus 0.12 and we get 0.53 meter. So we have this distance now 0.53, and for the anti-clockwise moment, we have this force T cos of 40 times, and the distance of T cos of 40 from the pivot is also 0.325. Now, since we have to find the tension T, you can just put this entire expression or cos 48 times 0.325 is being multiplied with t on the right side. When you shift it to the other side, so we get 0.325 times cos of 40 equals to t. So put this entire expression on your calculator and it gives you the final value for the tension, which is 46 Newton. The stress in the wire is 1.5 into 10 to the power of 7 Pascal. Determine the radius of the wire. So the formula for stress is force over area. So we are talking about this wire. This was the wire, and we know the tension in the wire is now 46 Newton. So that means we know the force. Now, since this wire is actually cylindrical in shape, and the cross section of this wire is a circle, and the area of a circle is pi r square. So we want to find the radius of the wire, right? So let's swap the places of stress and area. Area is equal to force over stress. So we can calculate the area first and then later equate it to pi r square and calculate the radius. So force is 46 and the stress is 1.5 into 10 to the power of 7. So we get 46 divided by 1. We have 3.07 into 10 to to the power of minus 6. So once you have the area and you equate it to pi r square, so this pi is being multiplied with r square when you shift it to the left side, it will be divided, and to get rid of the square, we take square root, and this is how we calculate the radius. And the final value for the radius is 9.9 into 10 to the power of minus 4. So we always have to give the answers to two significant figures. More items are added to the shelf, doubling the stress in the wire. The wire is made of the metal P from part A using figure 3.1 to state and explain whether the wire will behave plastically or elastically as the stress doubles. So, elastically means if it obey Hooke's law, and plastically means if it does not obey Hooke's law. So, does not obeys Hooke's law. So we have doubled the value of stress. The stress in the wire is 1.5 into 10 to the power of 7. So doubling the stress means the new stress is going to be 2 times 1.5 into 10 to the power of 7. So we have 3 into 10 to the power of 7 Pascal. So we have to use the figure 3.1. So let's look at figure 3.1. So when the stress is 3 into 10 to the power of 7, so you can clearly see that it does not exceeds the limit of proportionality or the elastic limit. So therefore it will behave elastically. So for 2 marks, we write first mark will be the elastic limit is not reached, and the other mark is it behaves elastically. Wire behaves elastically. With reference to the direction of transfer of energy, compare the oscillations of transverse and the longitudinal progress waves. So question number 4 part A, first of all we have to differentiate between the transverse and the longitudinal wave. So starting with the transverse wave. So what is transverse wave? A wave in which particle oscillates up and down or perpendicular to the wave direction. So particles, you can use the word vibrate, you can use the word oscillate. It's up to you. Word particles oscillate up and down or perpendicular. So you can either write up and down or you can just write perpendicular. Perpendicular to wave direction. Now, for the longitudinal wave, particles vibrate or oscillate left and right or parallel to the wave direction. So particles oscillate parallel to wave direction. So since we are not allowed to right on this side, on the margin line. So you have to be careful about the word limit of your sentence. Okay, a pipe is open at one end and closed at the other with a piston. The piston can slide freely and is at a distance of 4.5 into 10 to the power of minus 2 meter. So this distance is given. A loudspeaker is positioned near the open end of the pipe and emits a sound wave of a single constant frequency. A stationary wave is formed in the pipe. So, what is a stationary wave? The net transfer of energy is zero, or when two waves, when they travel in the opposite direction with equal amplitudes but in the opposite direction, so they cancel each other's out effect. So such type of waves is called as the stationary wave. On figure 4.1, draw a letter A at the position of an antinode. So antinode is the point where the amplitude is maximum and the node is a point where the amplitude is zero. So at these edges, we have antinode and this point we have a node. He was only asking us to mark the antinodes, so you can just mark the antinodes. The speed of sound in air is 340 meter per second. Determine the frequency of the sound wave. Now remember, the distance between a node and an antinode is equal to quarter of the wavelength. This symbol is for the wavelength. So the distance between node and antinode is given, which is 4.5 times 10 to the power of minus 2, equating it to lambda by 4. So this 4 will be multiplied with 4.5 into 10 to the power of minus 2, and we get how much? So 4 into 4.5, we get 1.8 into 10 to the power of minus 1, or you can write it as 0.18 meter. The speed is already given to us. We have to find the frequency. So if we use the formula V is equals to F lambda, now since we have to find the frequency, so make F as the subject. So we can express F is equals to V over lambda. So speed is 340 and the wavelength is 0.18. So you divide it and we get 1900 hertz. So remember, node to antinode, the distance is equal to quarter of the wavelength. However, if it's node to node or antinode to antinode, so it's equal to half of the wavelength. The piston is moved to the left. The frequency of the sound wave emitted by the loudspeaker is then changed so that a stationary wave is formed with same number of antennas as in figure 4.1. Later explain the change that is made to the frequency of the sound wave. So let's say if we move the piston to the left, so this is assuming that this is the new position of the piston. So we want to have the same type of wave. So this is how. So the distance of piston to the loudspeaker, or basically the distance between node and antinode increases. So it means that the wavelength will also increase. If we increase this length between the node and the antinode, so its wavelength will also increase. So we say distance between node and antinode increases, so wavelength also increases. So we get 1 mark for this. Now to identify what will happen to the frequency. So we know the relation V is equal to F lambda. And if we shift lambda to the left side and V is constant, so we say that frequency and wavelength are inversely proportional to each other. So if the wavelength is increasing, so we have to lower the frequency. So the other mark is the frequency is lower. In question number 5, part A, define the electric potential difference. So, electric potential difference, or we call it as voltage. So, if you remember the formula for voltage, which is work done over charge or energy over charge. So, potential difference, we can write it as work done per unit charge across an electrical component. So work done per unit charge across an electrical component. So by electrical component we mean it can be across a resistor or it can be across a lamp, a heater, any electrical appliance in a circuit. That how much energy is needed to drive the charge from one end to the other end of the across the electrical component. A power supply, three resistors and a component X are connected in the circuit shown in figure 5.1. The power supply has an EMF of 230 volt and negligible internal resistance. The current in the power supply is 7 amperes. Identify the component X. So this component X is the symbol for a heater. Show that the potential difference across the resistor of resistance 0.86 ohm is 6 volts. So before we do the calculations, let's see which resistor is in series and which one are in parallel to each other. So this is the positive end of the battery. The current starts traveling from this end. It follows this path. On this node, it has two paths for the current. So this is the I1 and this is the I2. So this is the total current which is divided into I1 and I2. And we also say that 2.4 ohm and X I1 will pass through both of these resistors because these two are in series with each other. However, their series combination is in parallel with 170 ohm resistor and their combined resistance is in series with 0.86 ohm. So we know that how much current is traveling through 0.86 ampere. So it's 7 ampere. So we know the current, we know the resistance, and we just have to find the voltage. So we use the formula V is equal to IR. So the current is 7 and the resistance is 0.86 and we get 6 volt or 6.0 volt. Now determine the current I1. Now since we know that the voltage across the 0.86 ohm resistor is how much? It's 6 volt. And this 0.86 ohm resistor is in series with the combined resistance of this entire thing. And in series, the voltage is always divided. So let's say if this resistor gets 6 volt, so the rest of the voltage is across the parallel combination of these three 2.4 ohm resistor, heater, and the 170 ohm. So, how much is it going to be? So, the voltage across them will be 230 minus 6 volt. So, that is 224 volt. So, the voltage across this whole thing is 224 volts. Now, we know that in parallel the voltage stays constant. So this 170 ohm resistor gets 224 volts and the combined resistance of 2.4 ohm and X gets the voltage of 224 volts. So I know the resistance of this 170 ohm resistor and I know the voltage across it. So I can find the current I is equals to V over R. So I is equals to V over R. Voltage is 224 and the resistance is 170. So we get 1.3 ampere. Out of this 7 ampere current, we have 1.3 ampere current passing through 170 ohm and the rest of the current is passing through the other branch in the form of I1. So I1 can be calculated as total current minus I2. So the total is 7 minus 1.3 and we get 5.7 ampere. Calculate the potential difference across the component X. So we have to find the voltage across this resistor now. Now we know the current that is passing through the resistor 2.4 ohm. Let me mark the voltage across this 2.4 ohm resistor as V1. So if I want to find the V1, I can use the formula V is equal to IR. So current will be 5.7 ampere and the resistance is 2.4 ohm. So 5.7 times 2.4 we get 13.68 volts. Now 13.68 volt is across 2.4 ohm resistor. However, the total voltage across 2.4 ohm resistor and X is 224 volts. So if we just simply subtract the voltages, so we can get the potential difference across X. So Vx is 224 minus 13.68 and we get 210 volts. Calculate the power dissipated in the component X. Now we know the voltage across the resistor X and we also know the current passing through resistor X, which is I1. So we can find the resistance of this, or we can directly use the formula for power, which is P is equals to IV. So if we use the formula P is equals to IV, current passing through the resistor X is 5.7 amperes and the voltage across the resistor X is 210. So if we multiply these two, we get 1197 watt. Now you can use another way. So that was the first. The other way we can find the resistance R is equals to V over I. So the voltage across it is 210 and the current is 5.7. So we get 36.84 ohms. Now you can use the other formula, which is P is equal to, either you can use P is equals to I square R, or you can use P is equals to V square over R. 5.7 square into 36.84, and we get 1197 watt. Or the other third formula is P is equals to V square over R. So the voltage across X is 210 square divided by 36.84. So you get the power and you round it off to two significant figures, so we get 1200 watt. So this is the power dissipated. Now, the purpose of the circuit is to provide power to component X, determine the percentage efficiency of the circuit. So the formula for the percentage efficiency is power output over power input, multiplying it with 100%. So we've got the power across the resistor X, which is 1200 watt. Now we have to find the input power, and for the input power we are always talking about the power supply. So we have to calculate the power of supply, or maybe the cell or the battery or any power source that's given to us. So we can use the same formula, P is equals to IV, to calculate the input power. So the current supplied by the battery or the cell is 7 amperes and the voltage is 230. So 7 into 230, we get 1610 watt. So put the value in the expression, put the entire expression on your calculator, and it gives you the final answer, and that is 75%. So we get 1200 divided by 1610 into 100. So we get 74.5%, and if you round it off to two significant figure, so we have 75%. The resistor of resistance 170 ohm is removed, leaving an open circuit in the lower branch of the circuit. There is no change to the resistance of component X. State whether the current in the power supply increases, decreases, or remains the same. Now just remember one thing, current is inversely proportional to resistance. So if the resistance of the circuit decreases, the current will increase, or if the current of the circuit increases, or if the resistance of the circuit increases, then the current decreases. So basically, let's look at this diagram, and he's saying that we have removed 170 ohm resistor. If you remove this 170 ohm resistor, it means there is no more resistance that is in parallel to 2.4 ohm resistance and the resistance X. So if that's the case, so all three of these resistor 0.86 ohm, 2.4 ohm and the heater X, all three of them are in series, and when all three of them are in series, so the resistance will increase, and when the resistance of the circuit will increase, so the current of the circuit decreases. So we write current decreases as overall resistance of circuit increases. In question number 6, part A, compare an alpha particle with a beta positive particle in terms of their masses and charges. So, if we talk about the alpha particle is similar to that of the helium nucleus with a charge of plus 2 and a mass of 4 AMU. So, it has a charge of plus 2 and it has a mass of 4 AMU or atomic mass unit. Now, if we talk about the beta positive particle, so it has a charge of minus 1. Oh, it has a charge of plus 1 and mass of almost its mass is equivalent to the mass of an electron. So we say its charge is plus 1 and the mass is 1 over 1840 atomic mass unit. Now we have to compare the masses and the charges of alpha and the beta positive particle. So based on this information, we will write the mass of alpha particle is much greater than the mass of beta particle. Mass of alpha is much greater than the mass of beta positive, or in brackets you can just simply write that mass of alpha is 4 AMU. AMU stands for the atomic mass unit, where one atomic mass unit is equals to 1.66 or 1.67 into 10 to the power of minus 27 kg. So if you multiply the given number with this value, so you can convert its mass into kgs as well. And mass of beta positive is 1 by 1840 atomic mass unit. Now in the second, we have to compare the charges as well. Both alpha and beta particles are positively charged. Both alpha and beta are positively charged. And the third point is alpha has double the charge of the beta positive particle, or you can just simply give the values in the brackets as well. Charge on alpha is plus 2 and beta positive is plus 1. So it clearly indicates that alpha particle has double the charge compared to beta positive particle. Nucleus P undergoes alpha decay to form nucleus Q. Nucleus Q then undergoes a further decay to form nucleus R. The proton and nucleon numbers of P and R are shown in figure 6.1. On figure 6.1, draw a cross to show the proton number and the nucleon number of Q. Label your cross Q. So P undergoes alpha decay. So P undergoes alpha decay to form Q. So when there's an alpha decay, so we know that, okay, we already know the proton and the mass number of P. So the proton number is 84 and the mass number is 216. When an alpha particle is emitted, so we subtract 2 from the proton number. So the proton number of Q is 82. And we subtract 4 from the mass number. So the mass number or the nucleon number of Q is 212. So 82 correspondingly 212, this is the position for Q. State the name of the particle emitted as Q decays to form R. So when Q decays to form R, let's write down the equation. Q has an equation of 82212 and R has a proton number and the mass number of 83 and 212. So there's a particle X. We don't know which particle is this, but we do know one thing, that the sum of proton number on the right side should always be equal to the sum of proton number to the left. So if there's an 83 over here, so if I put minus 1, so 83 minus 1 is equal to 82. Same goes for the mass number as well. So the mass number of X is 0. So the sum of 212 and 0 is equal to 212. So a particle with minus 1 as the proton number and a mass of 0. So we have beta negative. So this is beta negative particle. Negative particle. Now, remember one thing, whenever a beta negative particle is emitted, let me rewrite this equation. Since we know that it's the beta negative particle, so whenever a beta negative particle is emitted, an antineutrino is also emitted. So, an antineutrino. Now the antineutrino has no charge and the mass is negligible. So it does not affect the equality of the sum of proton numbers to the right and the sum of proton numbers to the left, and same for the masses numbers as well. So when there is a beta negative particle that is emitted, an antineutrino is always emitted. However, if a beta positive particle is emitted, then a neutrino is emitted. In part C, before the alpha decay, P is traveling at a constant velocity. We don't know the value of the velocity, so it just travels at a constant velocity v. After the decay, Q has a velocity of 1.3 into 10 to the power of 5 meter per second at an angle of 68 degrees. The alpha particle has velocity of 150 into 10 to the power of 5 at an angle of theta to the original path of P as shown in figure 6.2. Use the principle of conservation of momentum to determine theta. So the principle of conservation of momentum says the sum of momentum before the collision is always equal to the sum of momentum after the collision. But remember, whenever there is components that are involved, so we have to deal with the horizontal momentum and with the vertical momentum separately. So this vertical component, the side which is opposite to the angle, it gets the sine part, 150 into 10 to the power of 5 sine theta, and this horizontal component of the velocity is 150 into 10 to the power of 5 cos of theta. Now let us just draw the component for the velocity of q. So if this angle is 68, so this angle is also 68. So the component opposite to 68 degree will be 1.3 into 10 to the power of 5 sine 68, and this horizontal component will be 1.3 into 10 to the power of 5 cos of 68. Now, based on the principle of conservation of momentum, his initial vertical momentum must be equal to the final vertical momentum. Now, please remember one thing. Whenever you're dealing with momentum and you have these velocities, if you're considering the upward direction of the velocity as plus, so the lower direction of the velocity will be considered with a minus sign. Similarly, if the right direction of the velocity is considered positive, so the left direction of the velocity will be considered negative, or you can do it vice versa as well. Now, initial vertical momentum is zero since he was traveling with a horizontal velocity. Now, considering the final vertical momentum, so we find the mass of the alpha particle and the q. So mass of alpha is 4 AMU, atomic mass unit, and I said when you have to convert it into kg, so you have to multiply it with 1.66 into 10 to the power of minus 27 kg. So 4 times 1.66 gives us how much? So 4 into 1 point, we have 6.64 into 10 to the power of minus 27 kg. Similarly, let's find out the mass of Q. So the mass of Q, the nucleon number of Q is 212 AMU. So if we multiply 212 with 1.66 into 10 to the power of minus 27. So 1.66 into 212 we get 351.92 into 10 to the power of minus 27 kg. Now let's find out the momentum of alpha particle first. So momentum of alpha particle, momentum is the product of mass into velocity. The mass of alpha particle is 6.64 times 10 to the power of minus 27, and the vertical velocity of the alpha particle is 150 into 10 to the power of 5 sine theta, plus mass of the q is 351.92 into 10 to the power of minus 27 times the vertical component of the velocity is minus 1.3 into 10 to the power of 5 into sine 68. So this is the equation. Now we just have to solve and simplify. So just by multiplying 6.64 into 10 to the power of minus 27 into 150 into 10 to the power of 5, we get 9.96 into 10 to the power of minus 20 sine theta. Now plus minus, we have a minus sign here, and if we multiply 351.92 into 10 to the power of minus 27 with 1.3 into 10 power 5 into sine 68, we get 4.24 into 10 to the power of minus 20. Now, if we shift this to the other side, we have 4.24 into 10 to the power of minus 20 with a plus sign when you shift it to the left. And then we have this. If you divide this 9.96 into 10 to the power of minus 20 by 4.24 into 10 power minus 20, so we get 0.426, and that is equal to sine theta. So sine theta is equal to 0.426, and if you shift sine to the other side, we take sine inverse of 0.426 and the final 25.2 degrees, and we have to give the answer to two significant figure, so we write it as 25 degrees. Now in the last part, he wants us to calculate the kinetic energy of the alpha particle. So in order to find the kinetic energy, the formula for kinetic energy is half mv square. So we know the mass of the alpha particle, that is 6.64 into 10 power minus 27, and we know the velocity of the alpha particle. We'll use the resultant velocity, neither horizontal nor the vertical component. So resultant velocity is 150 into 10 to the power of 5, 150 into 10 to the power of 5 whole square. So you put the entire expression on your calculator and we get 7.5 into 10 power minus 13 joule. So that's it. Thank you so much for watching.